So in this video I want to talk to you guys about recognizing reactions when you have a certain type of reaction. Now I'm going to keep this video pretty short, there isn't that much to it. The goal of the video is for you guys to look at a bunch of reactions and be able to tell what sort of reaction do I have. And when I say what sort, there are 5 different types that I want you to be able to pick from. There is a 6th type called redox reactions that we're not touching on this video. We'll talk about those later. All right, they're kind of their own separate entity, but they do fit with these. But right now, all I want you to be able to see is, if you're given a reaction, it's going to be one of these 5 types. All right, and for example, if you have a reaction where 2 things go together to form 1, or say 3 things go together to form 1, or 3 things go together to form 2. So you have more things on the left than you do on the right. You have more molecules on the left than on the right. That's called a combination reaction, just like things combining together. Then there's the opposite of that, where something breaks down into 2 smaller things. All right? And that's called decomposition. If you have one compound that breaks up, for example iron sulfide, if you heat that up, this is iron 3 sulfide, if you heat this up, it breaks down into iron and sulfur. So you had 1 molecule on the left and in this case 5 molecules on the right, so that definitely broke down. That's decomposition. Alright, so it doesn't have to be 2 molecules, but it's 2 types of molecules. One type is iron, one type is sulfur. And then we have what's called a single replacement. And so really what's happening here is you have some bilinomates here that comes along and grabs something out of another molecule. Usually the guy on its own is a metal, and over here is another metal with a non-metal. And what happens is the other metal grabs the non-metal from the first guy and gives you this. So you had 2 molecules at the start, you've also got 2 at the end. However, in each case, in the products, the reactants on the products, you have a metal on its own. For example, copper, when it reacts with silver nitrate, the copper grabs the nitrate from the silver, says, hey, piss off, I want this for my own, and grabs it. So in the product, the copper's got the nitrate, and the silver, boohoo, has been left all on his own. But there are 2 molecules on the left, 2 molecules on the right. They've just kind of switched places. Double replacement. This is where everything switches. The analogy here is you have couples going to a swingers party. Now, I don't know who of you know what a swingers party is, but the idea behind a swingers party is you arrive with one person and you leave with somebody else. We're assuming this is a heterosexual analogy, so we have a heterosexual swingers party. If the guys are A and C, if guy A arrives with girl B and guy C arrives with girl D, then guy C leaves with guy, oh bollocks, I'm getting confused. Guy C leaves with girl B and guy A leaves with girl D. In other words, the partners switch. Alright? In chemistry terms, A and C are metals, so they switch their non-metal partners. Barium, if you imagine barium's the guy, potassium's the guy, chlorine's the girl, sulfate's the girl. Barium arrives with the chlorine because he's leaving with somebody else, he's going to leave with sulfate, so therefore he leaves with sulfate. Potassium arrives with sulfate, he ditches her and leaves with chlorine. And there you go. And the last type is actually very specific. Combustion reactions, to do with organic compounds, compounds containing carbon and hydrogen that burn in oxygen. Anytime something burns, you're talking really about a combustion. And we're being specific here that carbon molecules are the ones that burn. For example, methane, that's in natural gas, that is natural gas, it burns in oxygen to form CO2 and water. All carbon compounds burn to give these 2 products, and it says plus energy here. That means the whole reason these are used as fuels is because they give out a whole ton of energy when they burn. Otherwise you wouldn't use them to heat your house. So it doesn't matter if you've got 1 carbon, 2 carbons or 450 carbons, it's still reacting with oxygen to form CO2 and water. So those are combustion reactions, very specific. So when we go to these 4 reactions, all I'm going to ask you to do is to predict what sort of reaction is it. Well, when we look at this top one, first of all, the states are completely unimportant. All right. The coefficients are not particularly important either. You have one molecule here that somehow splits into 2. One molecule in the reactant, 2 molecules in the product. So this guy has split up. Meaning, if it's split up, that's saying it's split up into 2 things, therefore it's decomposed. That is a decomposition reaction. Decomp. When we look at the second one, notice we've got 1 molecule, 2 molecules on the left, and 2 molecules on the right. Again, the coefficients are not particularly important. We've got an equal number of molecules on each, or an equal variety of molecules on each side, which actually narrows down our possibility. It can only be either single replacement or double replacement. We know it's not combustion because we don't have oxygen or carbon, or we don't have carbon-containing compounds as we do here, and we have metals. So that means either this is a single replacement or a double replacement. But in single replacement, we have metals on their own in the reactants and in the products. Here we don't have metals on their own. This is the analogy of the swingers party here. The barium arrives with the chlorine, leaves with the carbonate. The potassium arrives with the carbonate, leaves with the chlorine. This is called a double replacement. Replacement because the metals are replacing the counterions. Double replacement. Alright. When we go to here, this one specific, it has a CH4. This is a carbon-containing compound. This is methane burning in oxygen. So anytime you see something that's just carbon and hydrogen and then you've got oxygen here and you know it's producing CO2 and water, that always means that's combustion. That's very specific. When we look at the last one, we got 1 molecule, 2 types of molecules on the left, 2 types of molecules on the right. All right. But notice on the left, one of the species is by itself, and on the right, one of the species is by itself. So this one is kind of like double replacement, except you don't have a metal with a non-metal here and a metal with a non-metal here. But you do have some exchange happening. This is an example of a single replacement, where the magnesium comes along and grabs the chlorine from the HCl, taking it for itself and leaving the hydrogen on its own. So this is what we call a single replacement. Alright, so we'll see some more of these in class, but basically that's what you look for. You're looking for which of these 5 reactions does your particular reaction fit, and that is the way it works.